Today we're going to work on actually drawing and identifying rotation images of figures. For the most part, we'll work on triangles. I mean, if you can rotate a triangle, you can rotate anything. There's way less vertices, less things you have to do to get it done than, say, an octagon or a decagon or some bigger polygon. Some odd-shaped. I mean, we could rotate a picture of a frog if we wanted to, but it'd take a lot of time to do that. And so we'll stick with the simpler figures. If you can rotate a triangle, you can rotate anything. If you can throw a wrench, you can throw a dodgeball, right? Yeah. Oh, if you can dodge a wrench, you can dodge a dodgeball. Thanks. All right. Let's move on. We have one page of some kind of wordy notes, so I'll let you copy them and then we'll talk about them. I'll pause this when we all get down to the orientations the same. I'll raise it up so you can see the figures. Okay, some of you are still finishing. That's okay. I'm going to talk about what's written here. When we look at the picture, some of this might make more sense. Simply at the beginning, we're just talking about describing rotation. You need to know the center of rotation. That center is always a single point. Sometimes it's a point on the figure. Sometimes it's a point somewhere else. The center rotation for the activity we're working on was always the point of intersection of the lines, which in that case, on all of those examples, was the origin of the coordinate plane. In this picture, when I move it down, the picture down here is the center is R, and it's part of the figure. And then we need to know the angle of rotation. A positive number of degrees. For this book and what we're covering in here, what I've written here is correct. Okay? Actually, I had a student helper a year ago, and she put some of this together for me. I showed her what I wanted to put in the notes. And anyway, this is what the book is telling you. The reality is, in math, a clockwise rotation is negative, and a counterclockwise rotation is positive. Okay? That's the way it works in math. And so, if we're going, remember the, oops, let me get a marker here. If we're going the hands of a clock, this is 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock. The hands move this way, so that's clockwise. That's going to be a negative rotation. Okay? If we go this way, that would be a positive rotation. Okay? That's universally known throughout math. Okay? So, unless you're told otherwise in a very specific situation, whenever you're going counterclockwise, that's going to be a positive rotation. Whenever you're going clockwise, it's going to be a negative rotation. And if we read on here, it says, and whether rotation is clockwise or counterclockwise. Unless stated otherwise, rotations in this book are counterclockwise. Well, that's the reason they said a positive number of degrees, because they're always going to give you counterclockwise rotations. Now, yesterday in that activity, you were discovering, well, sometimes I rotated clockwise, sometimes I rotated counterclockwise. That activity was not part of the book. Okay, it's some extra thing we throw in there to help you understand the concept. Okay, so tomorrow we'll spend a couple minutes wrapping up that activity to make sure you understand what went on there, and then we'll move on. So in general, a rotation of x degrees about point R is a transformation in which the following are true. The image of R is itself. So just like when you reflect a point that's on the line, that point doesn't move anywhere, does it? When you reflect a point on the line over the line, it still stays on the line. If we reflect a point, here's my line, I have a point to the, let's see, that's to your left of it. I have a point to the left, and I reflect it over the line, I get a point to the right. But if my point is on the line when I reflect over the line, it stays on the line. Okay, right in the same place. Same thing with rotation. If we rotate a point around a point that is the center rotation, it doesn't change. And then for any point V, RV prime equals RV, and the measure of angle VRV prime is equal to X. The orientation is always the same. Let's stop right here. Let you copy this picture down, and then we'll talk about what those two statements are saying. Let's copy both pictures, and then we'll talk about what they mean. So, if we go back up to these rules. In general rotation of X degrees. Well, this is our X degrees. The measure of this line from here rotated to here. Okay? That's going to be our X degrees. That's the angle of our rotation. Now I chose to put it on RV and RV prime, and that matches this next statement here, okay? But the fact of the matter is you can measure this angle, RQ, let's go a different color here, RQ to RQ prime. That should be the same X degrees, okay? And if Bradley says, well, I want to go RP, well, RP's not really drawn there, is it? So if we put this line in, RP, this line here, RP prime, then this angle from here to here would also be X degrees. Okay? So what we're learning is you can take any point and its image point after the rotation. Sorry if I'm standing your way. You can take any point and its image point after the rotation, measure the angle between the two, and you'll find out what the angle is. Okay? Now, all of these are well, I'm sorry, I don't know why I was thinking 100 degrees. These are not 100 degrees, they're more than 180, okay? But, so what we would do, our protractors won't measure more than 180, do they? So we'll measure the other angle and have to subtract it from what? 360. So if I wanted to find out what this was here, I'd take a protractor, which is hiding up here. Put it on this line right here. So that 0 is on RP, segment RP. Then I'm going to measure the angle starting, remember, start here at 0 on this side and measure to here. Okay? And I'm going to measure that angle, and in this case it is 137. 137. Okay? So that's 137 degrees. So if that's 137 degrees, what is this angle measure right here? How far is it all the way around the circle? How far is it all the way around? Jeez, it looked like I used a circle, didn't it? That's pretty close. How far is it if I connect the green and the yellow, this green and this yellow here? If I connect that and go all the way around, how many degrees is that? Go ahead.
223.
No. Go all the way around. All the way around is how many degrees?
Oh,
360.
I was subtracting it already.
So all the way is 360 degrees. And so if I have this yellow portion from here to here is 137, then what does that leave left for the rest of this over here?
Yep, 223.
Okay, so you're saying 360 minus 137 is 223 degrees, right? And it appears to be true. Okay. Now 100. No. Yeah, right. 223. Sorry. All right. So the measure of that rotation would be 223 degrees. Okay, we find that just by connecting two of the points and measuring the angle. Now, I didn't have to connect P. I could have used RQ that was already there and checked it out with RQ prime, which is here. Or I could have used RV and RV prime, or I could have used, I guess that's it. I could have used the existing segments that were already there, but you don't have to. You can connect any of them, okay? For any point V, then say RV prime is equal to RV. I'm just rereading what's written right here. For any point V, RV prime is equal to RV. And the measure of angle VRV prime is X. And that's what we're just saying. VRV prime, this angle here, that's, we used the red one there. This angle is going to be X degrees. And we just discovered X is equal to how many degrees? 223, right? Okay. It says RV is equal to RV prime. This distance before the rotation is going to equal the distance after the rotation. Okay? And the last point of emphasis there is the orientation is the same. Let me try to clean this up just a little bit. This, that's fine. Must be if I draw that around the protractor, it doesn't treat it like a marker anymore. Anyway, I didn't realize that. The orientation is the same. So if I look at this orientation, RQPV, which direction did I go? Clockwise or counterclockwise?
Clockwise.
Clockwise.
So
I went RQPV. So if I do that on this side, RQPV is still clockwise, isn't it? That's what we mean by the orientation is the same. Okay? And if we connect that to what we were doing yesterday and the day before, we rotated by reflecting twice, right? What happens to rotation when I reflect once?
it flips it.
It flips it over. Remember, you look in the mirror, you raise your right hand to your right cheek, it looks like you're raising your left hand to your left cheek, right? That's what it looks like. The person over there, if Emily and I was playing this silly game where we're standing here facing each other and she was mocking everything I did, I touched my right cheek, she'd raise her left hand, touch her left cheek. Okay? So it's reversing, it's flipping over. Okay? But then we take that reflection and image and we reflect it again, it's going to flip over again, isn't it? And there's only two orientations. So when it flips over and then flips over again, it's right back to where it started. And so rotations, which occur by two reflections, gives us an orientation that's the same. Okay? All right. Enough for the notes. An example here. I want you to copy this picture down, but do it in the middle of your page where you have some room to work, and don't make it too big. This picture right here for those at home looking at this. Copy it in the middle of your page. It doesn't have to be perfect, just something like that. A triangle with three sides of different lengths. a point C not on the triangle and put it in the middle of your paper and don't make it too big so you have lots of room. Okay? I'll pause while you do that. So just to recap, since I forgot to turn it on, put the center of the protractor on the center of rotation, which is C, and line up, you'll see over here, I've lined up the base of the protractor passing through point O. I'm going to measure a 100-degree angle, which I see is not quite perfect, so we're going to try to make it perfect. 100 degrees right there. Okay? I'm going to draw a line through there, which I've already done. Okay? I'm going to draw that line through there. Then, I'm going to do this. Some people are really good at this, and after you've done a few, you can get your protractor out, measure all your 100-degree angles and stop there. And then get your ruler out and measure your distances. I'm going to go one at a time. Come on. I'm going to go one at a time so that you can see what's happening. So step 2 is measure the distance from O to C. Measure, I'm just going to write OC. OC with no symbol over it means the distance from O to C. Then find O prime, wrote the wrong letter there. Then find O prime so that OC equals O prime C. Okay? So I'm going to measure OC. So how long is OC? Can you girls see that from where you're at? Can you see it? How long is OC? This line right here, how long is that? Emily, can you see it? Can we see? How long is this line? Here's 1, 2, 3, 4, right? So we'll call that 4. Okay? So then I need to find O prime so that OC equals O prime. Now, it's hard to write in there exactly where to find it, but the reason I drew that first line is so that I knew what line C is on. Okay? So C has to be on that line I just drew. I'm sorry, I misspoke. C is always on that line. I meant to say O prime has to be on that line. And so we measure from O to C. We got 4. Now we're going to measure from C to O prime, which is right there at 4. So this point right here is O prime. Okay? That point is O prime. Now, everything else we do is a repeat of what we just did. So pick another point, Hunter, that we want to rotate around.
L.
L. So we're going to move L now. Whoa. So again, we go to O. Need a little bigger protractor so it reaches. Did I say O?
Yes.
I apologize, I keep saying my letters wrong. We're putting the center of the protractor on the center of rotation, which is point C. Okay? And we're going to, put the base on, I actually put the base, not the zero line. Put the zero mark on L. And so what I'm doing is I'm connecting this line, I did again, from C to L. I'm connecting the point C to L with the protractor. And we'll measure now 100 degrees. Okay? Counterclockwise. And so 100 degrees would go all the way to right there. Do you agree with that? It's going to be this edge of my little mark. I drew a mark that's, anytime I get close to the edge of that protractor, it thinks I want to trace the protractor, which is not what I want to do, but did it again. Anyway, it's right there. Okay? So I want to draw a line from C through that point. And so I can take my ruler. I don't have to put, I'm not measuring yet. Okay? And I'm just going to draw a line through there. The first one I already had drawn, but now I'm showing you actually how I did it. I took my ruler and I drew a line through there. Now, the reason I did that is I just found then that this angle is 100 degrees. The angle from L to C through that mark is 100 degrees. I'm making everything 100 degrees. You start with one point, put your protractor on the center rotation, put the other side of your protractor on the point you want to move, measure whatever angle they tell you. Okay? And then we go to the third one. Oh, let's measure that first. Sorry. I'm going to measure that. So put our ruler on C and measure the distance to L. I want to ask Emily to read that for me. It's about 6.5. Okay? So when I rotate that over to here, I want to measure about 6.5, which is right in there. And so my point right here becomes L prime. Okay? Rotations manually they're a jumbled mess at times. That's why I'm only going to give you 3 of them to do. Okay? And then the last one, I'm just going to jump down to this because if you're totally lost, then I'm going to need to work with you, or Mr. Dew is going to need to work with you individually anyway. So again, I'm going to repeat the process. Oops. Put the center on C and put the 0 mark passing through the last point B, and I want to measure 100 degrees. Okay? I want to measure 100 degrees now. After I measure 100 degrees, I draw that line, right? I'm going to move my protractor out of the way now I'm done with it. I'm going to draw this line from C, the center rotation, through a point. Okay? So I went 100 degrees, so the angle again, BC, B prime, that angle is going to be 100 degrees. And I just measured the distance from C to B now. How far is that? 7.2. I'm going to rotate this over. I'm going to measure 7.2, which is somewhere right in there. And I'm going to put my dot there. And that's going to be B prime. My B doesn't look very good, but that's what it is. Now I'm just going to use my line feature to connect O to L, L to B, B to O. Okay? Yeah. The most important thing about what we've covered today is on that previous page, the language, the terminology, understanding what's happening in a rotation. Actually being able to manually move them. Some of you will catch on to it quickly, some won't. There's another method we could use to do it. Mr. Dew and I each would prefer the other method. The reason I did it this way is that it better explains, it's practicing more the three concepts that are most important, which are the image of R is itself, if it's the center rotation. For any point V, the distance from the center to V prime will equal the distance from the center to the point. The angle is always going to equal the angle of rotation, and the orientation is always the same. There's really four things there because there's two in this one. Those four concepts are the most important things I want you to remember. Okay? All right. Your assignment's going to be, please write this on your paper. Don't circle them in your book. That really annoys me when you write in your book. 1, 3, 5. Oh, sorry. This is lesson 12.3. I don't know what page that is. 1, 3, 5. Then I want you to do 11, 13, 15, 17. These are not
11, 13, 17. 1, 3, 5,
1, 3, 5, 11, 13, 15, 17, and 19. And that's all we'll do. These three are the manually rotate like I was just trying to show you. Do them first, because you can't take the protractors, rulers home, and Mr. Dew and I won't be there, and you don't have time to do them all, but I'll give you some time to finish it tomorrow, the rotation part. Do the rest of these at home tonight. There's one thing I want to point out to you. If I do this octagon here, if I quickly put in all these lines from the center out to each of the vertices, okay? what is the measure of the angle represented by my circle there?
360.
360 degrees. Since it's a regular octagon, meaning all the sides, all these angles are the same, how would I find the measure of this one angle? Go ahead.
An octagon's 8, right?
Yeah,
So then you take 360 divided by 8.
that's right. 360 divided by 8, and I believe that's 45 degrees. Okay? So you take the total 360 and divide by how many equal pieces there are, and I'll tell you what that angle is. The reason I ask you that is if this is A and this is C, what's my angle rotation from A to C? 135. I have a 45, a 45, and a 45. So I have 3 45s. 3 times 45 is 135. Okay? That will help you on these last couple. 2 or 3 of them there. 2, I think. Just the last 2. Okay? So identify that kind of stuff. Alright, you have your assignment. I will post this, so if you want to look at it again tonight or part of it, you can. Sorry, that manipulation takes a long time.